Alright, so in part 2 of the tutorial, we'll learn how to use Google Vision AI API in Python. So the best way to learn how to use an API is go to different examples. And in terms of the examples, I won't cover every single features, just the features that I think are most useful in the real-world applications. But if necessary, I'll cover the rest of the features in a separate video. Now let's look at the agenda for part 2 of the lesson. So in terms of the examples, for lesson 1, I'll cover how to use Vision AI module. Then I'll go over how to use a module that I wrote called Google Vision AI.py module that simplifies the Vision AI module usage. And for lesson 1, I'll also cover how to use the label detection feature. And for lesson 2, here let me update the list. And for lesson 2, I'll cover how to use landmark detection, object detection, logo detection, followed by face and web detections. So these two features are going to be the most challenging features to work with, just because the output is going to return a variety of different structures of objects. Now let's start with example 1, which is going to be covering how to use the Google Vision AI module. Alright, so let me go into my project folder. Alright, so from the last lesson, we learned how to install a Python virtual environment, as well as we also install the Google Vision AI Python package. Now, there are two more packages that I want to install, which I forgot from the previous video. Alright, so the first one is going to be the pandas library. So I'm going to use the command pip install pandas. Now, the second library is going to be the payload library, which is an image manipulation Python package. And the reason why I want to install the payload library is because later on we're going to draw the boundary inside an image. And to install the payload library, we'll use the command pip install payload. Now let me go into my project folder. Right, so here in my image folder, I have a list of images that I'll be using later on when I go to different features. Now, to use Google Vision AI Python package in Python, right, so first we want to launch our code editor and make sure that you activate your virtual environment in the code editor as well. Right, so here I'm selecting my Google Vision AI demo virtual environment as the target environment. Now, from the import statement, I'm going to import 4 libraries: the IO library, OS library, pandas library. So this one's optional. The reason why I want to import pandas library is because we can easily manipulate the data pretty easily using pandas. And to import Vision AI Python package, so we'll type from google.cloud, we'll import the Vision module. Now, when it comes to using Google Vision AI Python package, it's a 2-step process actually. So step 1 is going to be preparing the image. Now, there are 2 ways we can load an image. So we can load an image locally, or we can load the image from a web URL. Now let's look at how we can prepare an image locally. Right, so first we need to open the image using the io.open method. So basically we need to open the image in memory. Then we'll unpack the image by string into an object. Then we'll pass this content object to the vision.image class. Then we'll create a vision.image object. And that's method 1, which is going to be load the image locally. Now if I want to load the image from a web URL, then we need to create empty vision.image object. And from the image object, we can specify the image URL using image.source.image URI attribute. And once we prepare the image, we need to set up the authentication. Right, so the way how Google Cloud authenticate your account is using a service account client file. And it's going to look at an environment variable called Google Application Credentials. Now here, let me go ahead and insert my code snippet. So here I'm creating an environment variable called Google Application Credentials using the OS module .environment function. And I'll provide the service account file path to this environment variable value. And once we've done that, we can create the Google Vision client instance. And I'll name the object as client. And here, let me make the font size a little bit bigger. I noticed that it was too small. Alright, so from the Vision module, there's a class called image annotator client. And I want to create an instance of the image annotator client object. So basically, this class is going to look at the Google application credentials environment value, which is going to be the service account client file path. And it's going to look at the content of this file and use that to authenticate your account. All right, so for example, if I go in the, should me put this on the top. Now let me come out this line here. Now if I go ahead and run this code block. All right, so I was able to authenticate my account. Let me terminate this session. Let me try again. So here it was able to authenticate my account. All right, so I still don't know why. All right, so if you want to save the, or create not save, to create this Google application credentials environment variable permanently, you can create that using the environment variable in your system. All right, so if I go into my system properties and environment variables, so on my PC, I already create an environment variable that called Google application credentials. So basically, this image annotator client class is going to look at my environment variable on my PC instead. Anyway, let's move on. So once we create the image annotator client object, we can now take the client object and access different features. So from Google Vision API, we have around 12 different features. And as I mentioned before, I won't cover every single feature, just the ones that I think are most useful. Now, the first feature I'm going to cover is the label detection feature. Now, from the client object, we can use label detection method, and we'll provide the image to the image parameter. And I'll name the output as response. Now, if I go ahead and run the label detection method, oh, I forgot to create the image. All right, so I'm going to use this ds cf. Let me see which file is it. All right, this one right here. I'm going to use this photo that I took, which is going to be kind of like a view of city of Chicago. Now, if I go ahead and run the label detection method, and I'll print the response object, and it's going to return this a weird format output, and it's going to be Vision AI annotated image response object. Right, so it starts right here. Now let me copy paste the output to a notepad. Now if we look at the output right here, so basically we have a list of label annotations object. And you can treat each label annotations object as kind of like a name tuple. So for example, if you want to array every single label annotations object, we can say for label in response, and we should reference the label annotations field. And I'll print label inside the loop. Now if I go ahead and run this loop, it's going to print each label as its individual fields. Right, so for example, if I want to retrieve the description, so I'll reference the description attribute. And oh, I have a typo. And it's going to return urban design. So what this label detection feature will do is it's going to attempt to describe your image. Now if I run the entire loop, but this time I'm going to print other fields as well. We have score to represent the accuracy of the label description, and the topicality. So topicality and score are usually the same. I haven't seen any instance where the number are different. But for now, I'm going to print description and score for label detection outputs. Right, so if I go in the print loop, so from this image, we have this list of descriptions, such as cloud, sky, building, skyscraper, property, and a couple other things. So the label detection output is actually the easiest one to work with. So when we are working with other complex features, such as face detection or web detection, the output is going to be a lot more complex. So that's why I create a module to simplify the output. Let me grab the module real quick. Right, so I create this module called Google Vision AI.py. Inside this module, I created several functions and a class called Vision AI. Now, here let me import the Vision AI class from Google Vision AI module. Right, so from the Google Vision AI module, I create a class called Vision AI, which I'll show you how to use in a second. I also create a couple other functions to help me to prepare the image. So we have functions such as prepare image local, prepare image web, and two more functions called draw boundary and draw boundary normalize. Now to use the Vision AI class, right, so let me come out this code block. So I'll go ahead and create a Vision AI object. And from the Vision AI class, I need to provide the client object and the Vision image object. Now, because I haven't created the image object yet, assuming that I'm starting everything from scratch. Alright, so I'll go ahead and grab this prepare image local function. And I'll name the output image. Now, this function will take a file path as input. So I'll grab this variable here. Now I can prepare image by just writing 2 lines of code. And I'll provide the image object to the Vision AI class. Now let me go ahead and run this code block. Oh, I haven't imported the libraries yet. Now let me try again. I'm going to run these 3 lines. Now if I want to run the label detection feature, so I'll simply run the same function from the Vision AI object, and I'll name the outputs label detections and some method. Right, so if I go in the run line 32, and I'll print label detections. Now this time, the output is going to return a list with a list of named tuple. Now from this output, we can quickly look at what fields are available. And we can even use this label detections object to create a data frame object. Alright, so if I go in the run line 34 and 35, and it's going to convert the output as a table, which you can quickly export to a CSV file or Excel file. Alright, so this is going to be everything I'm going to cover in lesson 1. For the next lesson, I'll be covering how to use the landmark detection feature. In this lesson, we're going to learn how to use the landmark detection feature with Google Vision API. Now here, let me go ahead and import the Python libraries. Now going forward, this is going to be my default import statement. So I'll be importing the OS module. From Google.cloud, I'll be importing Google's Vision module. And from the Google Vision AI module, I'll be importing the Vision AI class, as well as the prepare image local function, prepare image web function, draw boundary function, and this one more function I forgot to import, which is going to be the draw boundary normalize function. Alright, so let me go ahead and import the libraries. Now I need to construct my image annotated client object, and I name the object as client. So I recommend that you save this code block as a code snippet for future usage. Alright, so let me go into my images. Now for demonstration purpose, I'm going to, let's see, I'm missing a couple photos. Let me grab the photos. Now for demonstration purpose, I'll use this photo right here, which is a photo of Statue of Liberty. Alright, so here let me grab the file name. And I'll create a variable called file path. Alright, so this is going to be the file path pointing to this photo right here. And because this is a local file, so I'll use the prepare image local function. And I'll switch image file with file path. Actually, let me rename this to image file path. Then I'll create a Vision AI object. And I'll provide the client and the image object. Now to use the landmark detection feature from the Vision AI object, I'll call the landmark detection method. And I'll name the output landmarks, and because it's going to return alerts if there are multiple items detected. And I'll print the landmarks response. Alright, so let me go ahead and run line 6 all the way to line 16. Alright, so here I'm getting an error. Let's see. Oh, because I'm using an incorrect client file. Right, let me try again. Now, from the landscape detection response, so Google Vision AI returns 3 items or 3 results. Now here, let's iterate each result one by one. So I can insert a loop. I can say for landmark in landmarks. And I'll simply print the first item. Alright, so if we look at the response, now from this landmark detection name tuple object, we have a description field which tells you the name of the landmark and the accuracy score and the bounding power value. Alright, so to finish the script, so here I'll print the description, the accuracy score, and to draw the bounding box inside image, I'll be using the draw boundary function. And I'll simply provide the file path. And the second parameter is going to be the vertices. As for the vertices value, this is going to be the bounding poly value. And the third parameter is going to be the caption. Now for the caption, it's going to be the description. Right, so if I go ahead and run this loop, now it should create 3 images. Now based on Google Vision AI's model, so it was able to print different results. Right, so the first result is going to be Statue of Liberty National Monument. Now the second result is going to be Statue of Liberty. And also have Liberty Island. So this is going to be everything I'm going to cover in this lesson. For the next lesson, I'll be covering how to use the object detection feature. Alright, so in this lesson, we're going to learn how to use the object detection feature with Google Vision API. So the object detection feature is basically a feature to detect any physical object in an image. Now let's look at an example. Alright, so for the image, I'm going to use this gaming SATA image. So from this image, we have several different items. with a chair, a keyboard, a mouse right here, a microphone, monitor, and 2 plants. Alright, so let me go ahead and grab the file path. So this is the code snippet from previous lesson, and here I can simply update the file name. And I'll go ahead and create my image object. Next, I'll create my Vision AI object, and I'll provide the calling object and the image object. Alright, so from the Vision AI object, and use the object detection feature, we'll call the object detection method. And I'll name the outputs object detections. Alright, so let me go ahead and run these 2 lines. Now if I print object detections, and it's going to return a list of items. Alright, so we have house plant, table, computer, keyboard, and a couple other things. Now here I want to focus on the bounding poly value. Alright, so noticing that here, the x and y coordinates, the numbers are really small. And the reason being is because those numbers are normalized. So to draw the bounding box inside image using those coordinates, here let me erase object first. And this should be Perl. Now from the object detection record, we have name attribute and the accuracy and the vertices values. Now to draw the bounding box inside the image, which is going to be this image right here, we'll be using the draw boundary normalize function, and we'll provide the image file path and the object bounding poly value and the description of the object. Alright, so let me double check. I have a typo here. Right, so that fixes it. Now if I go ahead and run this loop, right, so I have a chair, lightning, computer keyboard, table, house plants, and that should be it. So using the object detection feature, the AI was able to detect these 5 items. Now this is going to be everything I'm going to cover in this lesson. For the next lesson, I'll be covering how to use the logo detection feature. In this lesson, we're going to learn how to use the logo detection feature with Google Vision API in Python. Right, so here in my images folder, I'm going to use this folder right here. Inside this folder, we can definitely see the Microsoft logo. Alright, so in my Python script, I'm going to insert my code snippet, and it's going to be the same setup for all the lessons. Now here, let me update the file path. Alright, so let me go ahead and run this code block. Now from the Vision AI object, we can use the logo detection method to detect logos in an image. And I'll name the outputs logos. Alright, so if I go ahead and create the logos object, and I'll print logos, and from the image, there's only one logo that is located, and it's going to be the Microsoft Corporation logo. Now in the image, I want to draw a bounding circle, basically circle the Microsoft's logo. Alright, so here we can insert a loop. We can say for logo in logos. Now from the logo detection object, we have 3 fields: description, score, and bounding poly. Alright, so for this exercise, I'm going to print the description, the accuracy score, and to draw the bounding area, I'm going to use draw boundary function. Now inside the function, I'm going to provide the file path, followed by the further C values. And it's going to be coming from the bounding poly field, followed by the description. Alright, so if I go ahead and run this loop, now it's going to return Microsoft Corporation with 93% of accuracy. And from the image itself, we have this yellow box that circles Microsoft's logo. And here's the logo description. So this is going to be everything I'm going to cover in this lesson. For the next lesson, I'm going to show you how to use the face detection feature. In this lesson, I want to cover how to use the Google Vision AI face detection feature in Python. Alright, so I'll be using this stock photo as demonstration. And here, let me zoom in a little bit more. Right, so from this image, we have several faces or several individuals. Now, if I count the individuals, we have 8 people in this photo. Now, to use the face detection feature using Google Vision AI API, alright, so I want to show you how we can use the client object, which is this image annotated client object, to detect the individuals first. Alright, so let me go ahead and create my client object. And the reason I want to do that is because there are actually quite a lot of information that's going to get returned. Now, once I create the client object, I can use the face detection method, and I'll provide the image, and I'll name the output as response. Alright, so here I haven't created the image yet, and let me put this right below the response statement. Alright, so let me go ahead and create the image. Now go ahead and run the face detection feature. Now if I print the response object, and oh, I have a typo. Right, so noticing that here we're getting a lot of information from this response object. So basically using the face detection feature, the AI engine is able to detect almost every single landmark or facial attribute from, actually let me go back, from each person's face. Right, so here I'm going to create an object called faces. And from the response object, we can use the face annotations attribute to return each face's property. Alright, so let me go ahead and create the faces object. Now here I want to insert a loop. I want to say for face in faces. And I'll print the first face object. And I'll put a break right here to stop the loop. Now if I go ahead and run this loop, now if we examine the output in the terminal, so here we have information such as the likelihood of each person's emotion state, such as whether or not if a person is happy, is sad, angry, surprised, and so on. And we also have the degree information, whether if a person's face is tilted, if so, by how many degrees. Now, I want to show you how to retrieve the landmarks property. Right, so from the face object here, we can reference the landmarks attribute. And it's going to return a list. In the list, each item is going to represent each facial attribute. Now at this point, we can insert another loop. We can say for facial attribute in face landmarks. So we can print the properties that are tied to each element. Right, so we can print the attribute name. So it's going to be facial attribute type. And because this is going to be a constant, so we can reference the name attribute. And to get the XYZ coordinates, so reference the position attribute, followed by the X, Y, OZ value. Alright, so if I run this loop, so these are all the facial attributes that we can get using Google Face Detection API. Now, in terms of using the Vision AI module, right, so let me go ahead and create a Vision AI object. And the method name is going to be the same, face detection. And I'll name the outputs faces. Now let me create the faces object. If I print faces, and from the Vision AI face detection method, so here we're going to get a face detection name tuple object. Inside the record, we have fields such as detection confidence, joy likelihood, sorrow likelihood, and so on. And the last field is going to be the bounding poly. Now, if I want to draw the bounding box in an image, so here I'm going to insert another loop. So for face in faces, and I'll put a break right here because I don't want to draw the bounding box for each person, just the first one. Now here, if we want to return some of the information, so we can basically reference the face detection record attribute. Right, so I can simply type detection confidence. And if I want to know if a person is happy, then I can use the joy likelihood attribute. Now to draw the bounding box in an image, I'll use the draw boundary function. And I'll provide the image file path and the bounding poly value from the face detection record. Alright, so let me go ahead and run the loop. Right, so in the terminal, we have a 96% of confidence that it was able to detect this individual's face. In terms of the happiness level, it's rated as very likely. And here we have this yellow rectangle that circles the first individual that Google Vision AI was able to detect. For the next lesson, I'll be covering how to use the web detection feature. Alright, so in this lesson, I want to cover how to use the Google Vision text detection feature in Python. Alright, so here in my image libraries, let me just pick a photo. Let's use this one. So this is a photo that I took at Popeye. Basically, it's a flyer that tells you what items are on discount for each day. Alright, so let me grab the file name. Alright, so let me go ahead and run this code block. Now, to use the text detection feature, from the Vision AI object, we want to use the text detection method. And I'll name the output as texts. Now, let me open the image real quick. Now, if we look at this image, right, so we have a couple texts. So like Popeyes, everyday, Monday, all the way to Sunday, and menu items and the price. Now, to be honest, I don't know what the output is going to be, but let's go ahead and find out. All right, so if I go ahead and run these two lines. Now, based on the text detection method, so we're going to have a list of outputs. Now, if I use the len function to get the element size, so from this text object, we have 64 items. Now, the first element is going to be the text itself. Right, so from this text detection record, we can print the description field. Actually, I should use the print function. Right, so it's going to basically detect most of the text blocks. So here we're missing a P. Each day is a menu item. And some of them are missing a couple characters. But that's okay because this image is not very clear anyway. Alright, so if we want to print every single result, but for this demonstration, I don't want to print all 64 elements. So I'm going to insert loop, and I'll wrap this output with the enumerate function. Now here I'll say for index and text, and from this output right here, I want to print the text description. And to draw the bounding box in the image, so I'll insert the draw boundary function. And I'll provide the image file path, the vertices, and which is going to be text.bounding poly. And for the description, let's do text.description. And since I don't want to print every single result, so I'm going to stop at item 4. So I'm going to insert if statement. If index is greater than 3, then I want to terminate the operation. Right, so here me import the system module. And I'll exit out the program. Now, if I go ahead and rerun this loop, oh, this should be a loop. Right, so let me try again. Okay, so if I print, actually not print, if I run the loop, and here's the first image, that returns the entire text. And it looks like I forgot to import the system module. But from the loop, we have 5 images returned. Right, so here's the first one, which is going to give you the entire text block. And after the first element, it's going to print the text individually. So here we have Popeye, well, the P. Next is this everyday text, followed by Monday, 2. And I think the next one is going to be letter P, but I'm not so sure. Right, so this is going to be everything I'm going to cover when it comes to how to use the text detection feature. And hopefully you guys find this video useful. Alright, so in this lesson, we're going to learn how to use the web detection feature using Google Vision AI in Python. So the web detection feature basically will scan a photo. Then the Vision AI will basically go to Google's database and to check whether or not if the image exists in other places, or if a similar image or images exist somewhere else. Now, for this demonstration, I'm going to use this Golden Gate Bridge photo that I took from Wikipedia. Alright, so let's see. Now, let me grab the file name first. Alright, so let me go ahead and create the Vision AI object. And I also prepare my image. Now, from the VA object, we're going to use the web detection method to return the results. And I'll name the output web detection. Now, if I print web detection, and it's going to return a pretty big list of results. Now, if I use the function to print the members, now from the web detection object, we have, let's see, so we have all these members that we can access. Now, to save you a little bit of time, I'm simply going to copy paste all the available fields. Now, the first attribute that we can access, which is going to be the web entities attribute. Right, so the web entities attribute is going to return the labels that describe the image. So if we look at the output here, so the first record is going to return Golden Gate Bridge as the description, and second record is going to return marine headlands as the description, with a pretty high score 2.0 and 1.03. Then we have San Francisco Bay with the score of 0.79. And the best case labels attribute is going to try to find the name of the actual place. In this case, it's going to be Golden Gate Bridge. Then we have 4 matching images and visually similar images. So these 2 attributes is going to return a list that contains the page URL that are linked to the image itself. Right, so for example, from the 4 matching images attribute, it returns a list. Inside this list, we have a list of URLs that returns the URL address that pointing to the exact same image. Now, if I go ahead and open one of the link, right? So from this website, sophiatalkscience.files.wordpress.com. So we now have the exact same image as the image that I downloaded from Wikipedia. And it's pretty useful if a photographer or if you're someone who likes to take a lot of photos and want to check if anyone is using your work for their own benefits. The visually similar images attribute is going to return a list that contains links that have the same similar images. All right, so let me open one of the links. All right, so if we put these two photos side by side, and despite that they look almost the same, and if we look at the composition, they are just slightly a little bit different. All right, so the last attribute is going to be this pages with matching images. So let me go ahead and run this if statement. Found the pages with matching images. So instead of returning individual URLs, this one's going to return 3 items. The first one's going to be the website URL that contains the image. Then it's going to return the 4 matching image URLs or partially matching image URLs. Alright, so let me run line 25 first. And here the URL attribute only returns a single URL. So basically, this is the URL that contains the matching image. Then we have the URLs that from Wikipedia, which is going to be the source. Okay, so I know why. Because here I'm only referencing the first image. Here, let me fix the code. So here we can say for web page from this output right here. Because I was expecting there are going to be multiple results, but I didn't notice that I only referenced the first element. Alright, so if I go ahead and run this loop, and this should be web page. Now let's just look at one of the items. Let me insert a blank line. Now let's look at the last result from this web detection pages with matching images result. So here we have the URL that contains a very similar image. Right, so here's the website. And we don't have any exact match images, but we do have a visually similar image. Right, so I'll go ahead and open this URL. So basically from this website, we should be able to locate this image that Google Vision AI API determines that this is a very similar image based on the image source that I provide. So that concludes this tutorial series, and hopefully you guys find this tutorial series useful. And feel free to post your question or your feedback in the comment section below. And don't forget to subscribe, and I'll see you guys next time. Bye bye.